Okay, in class example 1, it says evaluate the following logarithms. So to change these so that we can evaluate it, we're going to put them in exponential form. Just remember here that when we're doing that, we always keep the base the same. So this base is going to stay as a 3. So if I make this thing equal to x so that I can solve for it, the x now becomes the exponent, and the argument, or 81, it becomes the answer. So the way I like to remember this is what was separate, so the 3 and the x, they come together, and what was together, they separate. You can see that here. So we'll try that over here on this one here. So we'll make this equal to x. We'll say the base always stays the base. I start with that. What was separate comes together, so 4 raised to the x equals 64. So my argument from the logarithm becomes the answer. If I look over here, 7 raised to the x, remember I make it equal to x, equals 7. Okay, and we can even solve these. I probably should be doing that. So x is equal to 1. If I were to go back over here, 4 to the something equals 64. I think most of us should know that. That is going to be 3. So here x is equal to 3. If you don't know that, then we can do a base change. So I can take this 64 and I can just rewrite it as 4 raised to the 3. And if this is 4 raised to the x, my exponents are equal now. So I can say x is equal to 3. Back over here, I can do the same thing. I can rewrite 81 as base 3. So that's going to be 3 raised to the 4. And then 3 raised to the x. Now that the base is the same, I can make the exponent equal as x equals 4. And if you don't know right off the bat what these things are, you can just do a little bit of guessing and checking on your calculator and find it pretty simple. Okay, back over here, we have 12 raised to the x. Remember, the base stays the base, is equal to 1. And this is just something that we learned back in grade 10. Anything raised to the 0 is going to be 1. So this just x equals 0 here. If I want to change it to do the same base, you could think about this as just 12 raised to the 0. And you could approach it like this and make the base the same and then still say that x is 0. But I think most of us should feel comfortable saying, hey, I know that anything raised to the 0 is 1, so x has to be 0. And that's how you do class example 1.